Welcome students. Let us see this question. This question says a cork has weight mg and density 25% of water's density. So we have a cork and the weight of this cork is mg and the density of this cork is 25% of water density. We can indicate rho water, or we can say this is 1 by 4th of density of water. We can say the density of cork is 1 by 4th of density of water. A string is tied around the cork and attached to the bottom of a water filled container. So this container is water filled and a string is attached to the cork and it is fitted at the bottom. The cork is totally immersed in the water. Express the tension in the string in the terms of cork weight mg. So we have to find the tension in the string which is attached with the cork. So let us draw the free body diagram. So suppose this is a cork and this is a string attached to the cork from the bottom. So obviously the weight mg will be downward. So this is the weight mg and the buoyancy force will be acting in upward direction, that is the fb, right? So buoyancy force will act on this string as well. So we can indicate it by FB. So the tension, how much tension it will have, the net tension will be either FB minus mg or mg minus FB, one of them. So let us try to calculate the FB and mg, both the force. So let's calculate the FB first, that is the buoyancy force. So we know the expression for the buoyancy force or the concept for the buoyancy force. It is nothing but the weight of displaced liquid. It is nothing but the weight of displaced liquid or water. So how we can write the weight of displaced liquid or water? So weight, see, density is equals to mass upon volume. So mass is equals to density into volume. So the buoyancy force, it will be density of liquid. We can write rho density, that is the density of liquid into volume of displaced liquid, and this multiplied by g, the acceleration due to gravity. This rho into v will give us the mass of the displaced liquid, and when we multiply it with acceleration due to gravity, it becomes the weight of the displaced liquid. Now we have, see, my answer should be in terms of weight of cork. So I will try to write everything in terms of cork. See, we have the density of cork and density of water relation. So density of cork is 1 by 4th of density of water. So we can write density of water should be equals to, density of water is equals to 4 times density of cork. We want to write here density of liquid. So density of liquid should be 4 times into density of cork, right? This into C, volume of displaced liquid. What is the volume of displaced liquid? In the question, it is given that the cork is immersed totally. Please see, the cork is totally immersed. So the volume of displaced liquid will be same as volume of the complete cork, and this times into G. Now, if we see very carefully, this density of cork into volume of cork will give us the mass of cork into G. So this mass of cork into G will give us the weight of cork. This is the weight of cork. So we can compare very easily that the buoyancy force is 4 times greater. The buoyancy force FB is 4 times than the weight of cork. Weight of cork is also a force. So the buoyancy force is 4 times greater. So let me represent these information in our free body diagram. So FB is 4 times of mg, right? Where mg is the weight of cork. So this is 4 mg and this is a 3 mg. So how much tension will be? So the tension will be 4 mg minus mg, that is 3 mg in upward direction. So this will be our tension in the string. Let us verify the option. So option number D should be the correct answer. So I hope you have understood this question. This is a very conceptual question. So if you have liked this discussion, please like this video and subscribe this channel for such good questions. Thank you. Thanks for watching.